I really like this problem because it combines things we need to know about exponential equations and quadratic equations. So the first thing we need to know and the key to solving this problem is actually this one here. This one is very important. If it was another number, this would end up being a lot more difficult to solve. So because it's one, we're going to use a couple key facts about exponentials. The first thing we're going to look at is that, when a to the power of 0, with a being any real number, we know that that's always 1. And that can help us solve this because now we know for this equation to be true, we would know that the exponent would have to be 0. So if this exponent is 0, then we would get an answer of 1. So what we're going to do is solve this equation here, where we take x squared plus 9x minus 36, and we're going to set that equal to 0. Because that means the exponent is 0, and then our answer is 1. So to solve this, I'm going to factor it using the sum and product rule. And because a is 1, I don't have to use decomposition. So I'm looking for two numbers whose sum is 9 and the product is negative 36. And when I go through some of the factors of 36, I get the one that stands out is 12 and 3, and 12 minus 3 is 9. So what we're looking for is x minus 12, x plus 12 and x minus 3. And that would give us negative 36 and positive 9. And so what that tells us is that x is equal to negative 12 or x is equal to 3. So these are two solutions here. However, there's one more set of solutions that we need to look at. Because if the base of the exponent here, if the base is equal to 1, we know that 1 to the power of anything is 1. So 1 to the power of a, with a being any real number, is 1. So that's where this 1 comes in, and that's why I particularly like this question, because there's two separate exponential concepts here. So now we have to set the base equal to 1 and see if we can solve that. So we have x squared minus 7x plus 11 equal to 1. And to solve a quadratic trinomial, we have to set it equal to 0. So we're going to subtract 1 from both sides. Plus 10 equal to 0. I'm going to repeat using the sum and product rule. The a value, the coefficient of x squared, is 1, so we can we don't have to use decomposition here. We have a sum of negative 7 and a product of 10. So that's going to be two negative numbers, and that's going to be negative 2 and negative 5. So we end up with x minus 2, x minus 5 equal to 0. So therefore x is 2 and x is 5. So there are four solutions to this equation, four separate solutions: 2, 5, 3, and negative 12.